So let's start with some basics. Some of this might be review for you. Some words might be kind of new. First things first, a circle. The definition of a circle is the collection of all points in a plane that lie a fixed distance from a fixed point, known as the center. The measure of a circle is 360 degrees, and you name a circle by its center. So to name this circle below, all you have to do is write the word circle. And then whatever point representing the center, in this case, A is representing the center, we would name it circle A. That's how you name a circle. You have to write the word circle. Don't just write A, because then you're naming a point. So circle A. Radius is a segment drawn from the center of a circle to any point on the circle. So if we start at the center and go somewhere on the edge, that is your radius. So this segment right here, we'll call it AB, is your radius. It starts at the center, goes to the edge, halfway through your circle. A chord, that is how that is pronounced, chord, is a segment that has both endpoints on the circle. So one endpoint starts on the edge of the circle. It goes through the circle, and then the other endpoint's on another edge. That is a chord. We'll call it CV. That is a chord. Endpoint on the circle goes through the circle. Endpoint on the another edge. A diameter is a chord that passes through the center of the circle. So the diameter is a chord. It's a special type of chord because it goes through the center. So an example of a diameter would be, you start at the edge, you go through the center, you keep going to the other edge. We'll call it EF. That is a diameter. It's a chord because the endpoints are on the edge of the circle, but what makes it a diameter is because it's going through the center. Okay? So the center is EF. Or the diameter. Questions over that? Okay, so we'll practice it some more on this next example. We're going to use this circle to answer the following. List three segments that represent the radii of circle A. So you can give me a radius in circle A. Trent? AB, that's a radius. Goes from the center to the edge, which is another radius. AC. Goes from the center to the edge. That is a radius. And what's a third radius? Very good. And you could have named it BN, CN, DA. You don't have to start with the center. You could start at the edge and go in. Doesn't matter. Both are correct. Give a segment that represents the diameter. We look at what's the line that's going all the way through the circle and through the center. That is our diameter. Starts at an edge, goes through the center, goes to the other edge, DC. List all the chords that are currently drawn. Give me a chord. DB, very good. It's on the edge, goes inside the circle, and stops at the other edge, DB. What's another chord? DC, yeah, the diameter, remember, is a chord. So whatever the diameter is also a chord. Just a special type of chord. Questions over that? If we take a look at another part of a circle, it's called an arc. And it's literally a part of the outside of the circle, and it's made up of two distinct points. So it's just like a piece of the outside is what the arc is. And it's just like what you think an arc is. It's just a curved piece of the outside of the circle. There's three types of arcs we're going to talk about. First type you maybe heard before is a semicircle. Okay, it's an arc that's half of a circle. So if it's half of a circle, what would its measure be? What is it? 20. A full circle is 360. is 180 degrees. So a semicircle, half a circle, its measure is 180. The minor arc is an arc that's smaller than a semicircle. Okay? So if it's smaller than a semicircle, that means its measure has to be between 0 and 180 degrees. Because it can't be 0, because then it would be nothing. Okay? And it can't be negative, so it's between 0 and 180. A major arc is larger than a semicircle. So that means its measure is between 180 and 360. We can't go over 360 because it's a circle. So we take a look at this diagram below. We're going to use it to answer the following in example 2. It says name 2 semicircles that are in circle O. When naming 2 semicircles, we use, when naming semicircles, we use 3 points when you name a semicircle. Now, I like to name semicircles. I'll name one for you, and then someone can name another one. What I like to do, whenever you name an arc, you make an arc symbol, you make a mini arc, or you write the word arc. Both are acceptable. Okay. I start, because it's half of a circle, I start at the end point of one of my diameters. I'm going to start at D. Because I have to name 3 points. I'm then going to name a point next to it. So I'm going to go this way. I'm going to say A. And then I'm going to go to the other end point of my diameter. So there's my arc. That is a semicircle. So who can give me another semicircle? 3. DCB. D to C. 3. That is another semicircle. Yes. No. If you're asking in a semicircle, there's always going to be a point. Good question. Okay. And you could have said B, C, D, or B, A, D. Okay? Could you have said this? Could you say CBD? We look at there. CBD. That's the same exact letters, right? Would we go in that order on the circle? C to B to D. Is that a semicircle? No, that's almost the entire circle. So it's much bigger than a semicircle. So order is very, 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 very important. You have to go in the order of how they're written on the circle, or you're going to name a completely different arc. Okay? Make sure it's like angles. You have to go in order. Okay. 2. We're going to name 2 minor arcs. When we name minor arcs, we use 2 points. Use 2 points to name minor arcs. And those are just your tiny little arcs. So who can give me a minor arc? C? Yeah. Start at C, you end at D, there is a minor arc. C. What's another minor arc? What is it? D to A. Does anyone have any other ones, just for more practice? Parker, did you have a different one? CB? Yep. CB, that's a minor arc. It's less than 180. Trent, did you have another one? AB, yep. That's another minor arc. Less than 180. Sebastian? CA. That is another minor arc. Less than 180. So lots of correct answers. We just wanted 2. So go like about geometry. You can come up with all these different answers. And then lastly, a major arc. When naming major arcs, we use 3 points. Okay, I'll name the first one because I think major arcs are the trickiest. I'll start with, I always like to start with an endpoint of a diameter. I think it's helpful. So I'm going to start with D. And I'm going to go all the way to B. Then I'm going to go to C. That is a major arc. It's bigger than a semicircle. D, B, C. Okay. What is another major arc? What is it? A,
Oh, A, B, C.
ABC. That works. A to B to C. Celeste, did you have another one?
So, would you say D?
Yes, you could say DAC. D to A to C. That's a major arc. Yeah. Yeah, you can skip like I did, or you can just go to the one right next to it. You sure?
Okay. So the first one you said you went D to B to C.
Yes.
Could you go? What's the difference between like D? Could you go D A C?
Yeah. And actually, you're naming the same exact arc.
Like,
You're just using different letters.
Okay.
Yep. Nope. That doesn't matter. You can skip and go to here. You could have said DAC. You could have said DBC. It's the same exact arc. You're just using different letters to make it. Any other major arcs that we see? And that's the reason why we have different amount of points. Because with minor arcs, that's indicating to you because there's only 2 points there. That's telling you it's a small arc. So you're doing the shortest distance possible when there's only 2. So like here, CD, I know when I see that, oh, I'm just doing this little baby arc because there's only 2 letters. But when I have 3 points, like BC, that's telling me, oh, that's a big arc. Okay? So that's why you have to distinguish the difference between 3 points and 2 points. Because when it's only 2 points, you're going the shortest distance possible from C to D. Okay? Because you can also go this way, but then that's a really far distance. So technically that's a major arc. So you need another point to indicate the direction you're going. Well, there's only 2 points. You just go the shortest route. Questions over there? There's another important line involving circles that's on the outside of the circle, and it's called the tangent. Okay? And a tangent to a circle, no matter how far, how long the line is, how far it extends, hits the circle on the outside one time and one time only. Okay, that makes it tangent. So it kind of touches the circle and moves on. Okay. So if we look at this diagram, line M is tangent to the circle because we have a line. It touches the circle one time at point A, and then it keeps going on. If it hits more than one time, then it's a totally different type of line. Tangents only hit a circle on the edge one time. Right? Important fact to know is a tangent is always perpendicular to the radius of a circle. Okay? What type of angles are formed by perpendicular lines? We have 2 perpendicular lines. What kind of angles are always formed? Right angles. Very good. So that's really, really important to know. Or 90-degree angles, however you think. Okay. Whenever you have a tangent, if I draw in the radius from O to A where it's intersecting, that radius, OA, is perpendicular to line M, meaning they're creating right angles. It's a really important fact to know. Whenever you have a tangent line, you're always going to have a right angle with the radius. So we take a look at example 3. It says in circle K, AB is tangent to the circle at point A. If the radius of the circle has a length of 5 and the tangent has a length of 12, what's the length of KB? So we're trying to find KB. So I marked that with X. It said AB was the tangent, and it said the tangent was 12. So I'm going to mark that. It said the radius, and if I'm looking at my diagram, the only line that's left that can be a radius is KA. This is going from the center to the edge, and that's 5. Well, what do we know about a tangent line and the radius? They make what type of angles? They make right angles. They're perpendicular. So I know this is a right angle. Whenever I see tangent, I'm always thinking right angle. Okay? Well, what do you notice? What kind of shape do we have? What kind of shape do those lines make? A right triangle. And we're missing a side of a right triangle. How can you find the missing side of a right triangle? What can we use? Pythagorean theorem. Why aren't we going to use trig? Because we have 2 sides. So we use Pythagorean theorem. And we don't have the little angles. We can't use trig. Which one has to be our C? X. Well, not always X, but in this case, yes, X. Because it's what's across from the 90-degree angle, that's always your C. Then it doesn't matter. I'll make that my A, make that my B. Fill everything in, so we get 5 squared plus 12 squared equals x squared. So we clean this up. 5 squared is plus 12 squared is what? 9. What do we have to remember to do to both sides to get x by itself? Square root. Don't forget to square root. And when we do that, the square root of 169 is what? 13. So there's your answer. So think tangents, think right angles with that radius. And it doesn't matter wherever it is on the circle, the tangent line's always perpendicular to the radius. Right. Questions over that? So this last example, we're going to kind of tie everything together in one big problem. This is what your quiz is going to look like on Wednesday. Keep that. You'll have to practice with it too. But it's going to be found in one big problem. Use a diagram of circle J to answer the following. Name a radius. Who can give me a radius of the circle? Sarah? JK. Again, there's more than one right answer. You could have said JM or HJ, but JK is a radius. It's going from the center to the edge. Someone give me the diameter drawn. Okay. HM. Very good. Starts at the edge, goes through the center, goes to the other edge. That is a diameter. Name a chord. Name a chord that's not the diameter. Plus? GH. Good. And name it segment. GH. If you named it line GH, you're not naming a chord because it's going outside the circle. Chords start at the edge, go through the circle, and end on the edge. So you can name it like a segment. Who can name me a semicircle? And remember, how many points do we use to name a semicircle? 3. Who can name me a semicircle? There? MGH. Very good. M to G to H. That is a semicircle. And make your arc M, G, H. And more than one right answer, that's just one. Name a minor arc. Who can give me a minor arc? A little arc on this circle. GH. Just a little arc. GH. Good. And we use 2 points to name a minor arc. Who can name a major arc? What? Major. So H to M to K. That is a major arc. Okay. Who can name the tangent line? Ross?
NML.
Good. When we name lines, how many points do we use?
2.
2. So rename it. For 2.
NL.
NL. Good. Very good. You could have said NM. You could have said LM. NL is perfect. You could have named a segment. You could have said NL or NL as a segment. Lots of right answers. And again, it's tangent because it's hitting the circle one time on the outside. H says if the measure of the length of the radius is 8 and the length of MN is 6, so from here to here 6, what is the length between point J and point N? So we're trying to find from N to J. And I notice here is a radius. MJ is a radius. And it said that it was 8. Well, what do we know about a tangent and the radius? We just said that line was tangent to the circle. What do we know? What kind of angles do the radius and the tangent form? What kind of angles do those two lines form? 45-degree angles or 30-degree angles? What kind of angles do MN and JM form? What are they? 90. Yeah, they're right angles. They're always perpendicular to each other. They're always going to create right angles. Well, what can we use? What shape do you notice that we have? We have a what? Right triangle. What can we use to find that missing side of that right triangle? We're going to use strength. Can we use strength? Oh, Use tricks. We have these what? Something plus something equals something. I know you know this. You just don't say it. What is it? Pythagorean theorem. Yeah, we're gonna use a squared plus b squared equals c. Just like that last example. Whenever you have a radius and tangent meet, then create a right angle. And if you notice, we have a right triangle, so we can use the Pythagorean theorem to find that missing side. Which one has to be our C? X. Yeah, so what's across from the 90? It's not always X, but X happens to be what's across from the 90. So that's our C. And then I'll make that my N, and that my B. So we plug it in, we get 6 squared plus 8 squared equals X squared. So what do we get when we do 6 squared plus 8 squared? 100. And then what do we have to do to both sides? Square root. And the square root of 100 is what? So the length of that line is 10. Or the distance in between those 2 points. Questions over that? Again, this is very similar to what your quiz is going to look like on Wednesday. On a all big one big problem. No questions? Okay. The rest of the time is yours.